Hello, boys and girls. So, welcome to our new distance learning channel. I'm going to try and upload this. You would not believe what just happened. I had this one app and it did not work, and I probably did this lesson 3 times already. So, fingers crossed. Here's hoping for this one to be successful. Okay, so first of all, today we're going to do, I'm probably going to break it up into 2 parts. Part 1 and part 2, just to make sure that I don't have a ton of minutes to upload at once because I have really bad Wi-Fi out here. But today we're going to be doing equivalent fractions, and this is equivalent fractions part 1. And if you would now, if you don't have a pen or a pencil, go ahead and pause and go get yourself a pen and a pencil, because I would like you to follow along, take notes with me, and also I would like you to work the problems out with me. So go ahead and press pause and get that if you need that. Also, if you're taking notes and I'm going too fast, the beauty of this program is that you can press pause and then press play and you'll be right with me. Okay, so let's go ahead and get started. This looks familiar, right? Because in our Google Classroom, in the math classroom, I gave you this as a resource where you can print it at home if you have that ability. And this is your number line resource. This is your fraction strip resource. And this is another number line resource. Okay, let's go ahead and get started. Addition and subtraction of fractions. Let me get a different color here so you can see what I'm doing. Okay, equivalent fractions. So what they're saying is that 2/3 is equal, 2/3 right here is equal to 8/12. And if you look at this box, it is in 3 parts, right? Here's 1, 2, 3. Because the parts of the box is the denominator. Down low, the denominator. That equals how many parts. Now, the numerator equals how many are shaded. So you can see 2 are shaded, so that's a numerator. So same here. Denominator, there's 12. Okay, 12 pieces. So if you count them all, you'll get 12. But only 8 of them are shaded. Now, how are they equivalent? Using this formula, we'll get to it. But if I were to take 2/3, right, and then I take what goes into 2 and 3? If we're just doing math, down here, what goes in, see down here? What goes into 2 and 3? Well, 2 times 2, of course. 2 divided by 2, of course. Can 3 go into 2? No. One's odd and one's even. So the next one is 4. Does 4 go into both? Yeah, I mean, it can't go into it, but 3 times 4 gives you a number, and 2 times 4 gives you a number. So that's how you get your equivalent fraction of 8/12 is equivalent to 2/12. And they're showing in this green area, or fluorescent mustard color, the number line right here. You have 0/3 is equal to 0/12. 1/3 is equal to 4/12. 2/3, which we just did, is equal to 8/12. 3/3 is equal to 12/12. But remember, whenever you have the same number on top and bottom, that equals a whole number of 1. So see this 12 on 12? That equals a whole number of 1. Okay, so then coming on down here, right down here, the denominator stays the same when adding fractions. So if we go to our first example, and you look at this denominator stays the same. So the only thing you add when you're adding and subtracting fractions is the top, the numerator, which is 1 plus 1 is 2, and the third stays the same, which is over here. Same thing over here. We have 1/8, 3/8, 3/8. Well, that 8 stays the same, and then you just add the 1, the 3, and the 3, giving you 7. Okay, moving along. Now, let's count by quarter hours. So you're thinking about time, right? 15 minutes, 30 minutes, 45 minutes, an hour. 15 minutes, 30 minutes, 45 minutes, an hour. So if we count by fractions, you have 1/4 of an hour, 2/4 of an hour, 3/4 of an hour, and 4/4 of an hour. That means you just got to 1 hour, right? Now, if we kept counting, we would get 1 hour and 1/4, 1 hour and 2/4, 1 hour and 3/4, 1 hour and 4/4, which means now you're to hour 2. So then if you were continuing, you'd be on 2 hour and a quarter, which means you're not all the way to 3, but you're getting there. Okay, so that's if we're counting by fractions. Now, let's go down here. I'll try and go a little bit slower. I hopefully will get better at this, guys, so just bear with me. But if I go and I read this problem, 15 kilograms of rice are separated equally into 4 containers. How many kilograms of rice are in each container? Well, let's see. First of all, they're asking us how many kilograms of rice are in each container. And I also know that they gave me 2 important information that I need, facts that I need. 15 kilograms and 4 containers. Do you think that you can draw this story for me? Or think about it. Go ahead and press pause because I don't want to ruin it. I want to see you try. But press pause and think about it and then come back. So if I were going to try and draw this, I think I would do, since there's equally into 4, remember this is a key word, equally. So they're going to be, usually that equal stands for divide. Something needs to be put in equal, then you're going to be dividing it. So I would first start by drawing my containers. And again, they gave us 4. So I'm going to separate that into 4. And I know that all 4 of these containers are going to equal 15 kilograms, right? We know that because they gave us that information in the problem. And then this little guy right here equals 1 container. And we know that because we drew it. So 1 container, 2 container, 3 container, 4, right? So now I know that 4 units equals 15. I know that 1 unit equals, well, how am I going to figure out 1 unit? And, oh, it goes back up to this, equally. So probably 15 divided by 4. Now here's where our decimal expertise comes in hand. You guys are the experts in dividing decimals. And I can look at 15 divided by 4. Those don't go into each other equally, right? So let's go ahead and put the 15 in the dividend and put the 4 in the divisor. Okay, well, if 4 does not go into 15 equally, what am I going to have to do? I'm going to need to put a decimal. And then when we divide, what do we do with our decimals? We raise the roof. Okay, so you do that first. Now I'm going to go ahead and work. 4 goes into 15 how many times? Good, 3. 3 times 4 is 12. Subtract. 5 minus 2 is 3. We can't have a remainder because we have that decimal sitting there, and you guys know what we do when we have nothing there but we can't have a remainder. We put an imaginary 0. Good. And then we bring it down. Uh-oh, 4 is not going to go into 30 evenly, but how many times does it go into 30? Good, 7. 7 times 4 is 28. Now we're going to subtract. Uh-oh, I still have a remainder, guys. What are we going to do? That's right, we're going to put another 0, and we're going to bring that down. And now, guess what? 4 goes into 20 how many times? Bingo! 5 times 4 is 20, so now we're left with no remainder. And we're going to write it in a complete sentence. And we're going to say our answer, and it comes back to here. How many kilograms of rice are in each container? Each container holds 3.75 kilograms of rice. Period. Don't forget the period. Okay, next page. We're just going to reiterate 15 divided by 4 was 3.75. Now I want you to show me that as a fraction. Press pause and I want you to try and do 3.75. Listen, let's say it how we read it. 3, remember the decimal, and 75 hundredths. Go ahead and try to draw that as a fraction and press pause. Did you get 3 and 75 hundredths? Good. And then if we were to express 75 hundredths into its simplest form, go ahead and try that. 75 hundredths in its simplest form. Three and 3/4. Write your answer as a whole number and a fraction in its simplest form. And that would be a whole number and a fraction in its simplest form. Okay. Now, if you hear someone snoring, it's my dog Duke. He's laying right next to me, snoring like an old man. Okay, so now we have our number line. And if you were to cut or fold a piece of paper in half, that's kind of like what I think of when I look at this number line. So the zero's here and the one's here. So that means all of this is a whole. But if you only get to half, you're not to a whole. But if you do get all the way to the other half, then you made it to the whole. So when you look down here, this represents 1/2. These are all right here. This guy, this guy, this guy, and this guy. They're all equivalent. All they are is cut into more pieces. So all of them are cut into 2. So you'll see the denominator is always going to be 2 because the up and down cut is in 2. Okay? So you have one, remember the denominators, how many cuts there are pieces, and the numerators, how many shaded. So here we have 1 by 2, 2 by 2. This is our formula. 1 times 2 equals 2. 2 times 2 equals 4. And then same thing here. 1 times 3 equals 3. 2 times 3 equals 6. 1 times 4 equals 4. And 2 times 4 equals 8. So you have 1/2 is equivalent to 2/4, which is equivalent to 3/6, which is equivalent to 4/8. And they're all the same, guys. It's just here you get a bigger piece of the puzzle. Here you get smaller pieces, and the pieces get smaller and smaller. So right here, 1/2 equals 1 group of 2, 2 groups of 2, or 1 times 2 over 2 times 2, and you get 2/4. How are these equivalent? Can you show me 2/4 on the number line? So come up here, show me 2/4. Go ahead and press pause. So if this was 4/4, right? If these two are the same and this is 4/4, then we would have 2/4. right? 1/2 and 2/4. And I want you to find 2/4, and you just did it right there. Okay, I'm going to go ahead and I'm going to stop equivalent fractions part 1, and then we will come back for part 2. I want to make sure that this is working.